Hello, welcome back everyone to the series where we are reading Laravel code, the framework source code. And the last episode we stopped here in the handle request, right? This is the index. We already have the application kind of bootstrapped, and the handle request will, we saw how we got the request here, the capture method, and then that's being passed to the handle request. And now we can see the application handle request method, right? And in this episode, I will try to just focus on the making of the HTTP kernel, because that's a little bit more complex. And when we saw the container, we didn't see exactly how the make works, right? So let's dive into that. The episode will be just this call here. And hopefully we will be a little bit shorter and more focused on just one thing. So to do that, I created a documentation here to just understand how the make works and the container, right? So we can take a look at here. So the container make method, it's just a public method to call the resolve, right? And the make will call the resolve by passing the parameter, of course, that the container calls an abstract. And the abstract, it's just really any identification of a value that's contained inside your container. Right, so it could be a class, it could be a constant, sorry, not a constant, a interface. It could be just a string, like the app, it's registered against the container as just app. The events, it's the dispatcher, it's events. So anything that can identify something in the container, that's the abstract. So the make will call resolve passing that abstract that we passed, and in the case of the kernel, it's the contract, right? It's the interface, and the resolve will do things, and resolve, it's kind of a wrapper around all the logic here. It will call other methods, auxiliary methods, but that's where all the logic happens, and the resolve will return whatever it's needed to the make, and make will return to the client code, right? So resolve will work with alias, and alias is just another way to name something. So we will try to see if the thing you're trying to build, it's aliased, and if it is, get the alias and the concrete for that alias. And concrete here, it's actually the thing that needs to be built, right? It could be as well another abstract. So an abstract could point to another abstract that points to a concrete. That can happen, but we will take a look how that's being handled here. So it will take care of the alias, fire any callbacks, and this is just to allow custom code to do things when before it's resolving and after, right? Then it will try to get a concrete based on the context. And the concrete, again, it's the thing we want to build. Well, we use to build, right? It's the value that we use to build something to return. The concrete could be a callback. It could be a class, right? So in this case, this is where the implementation of that functionality that you can build something based on the context, right? It's implemented. Then it will try to handle the singletons. So if it's already created a singleton, not created but built, it would just return that, right? Then if it's not a singleton, if there's no contextual concrete, and the singleton, it's not returned, then we'll try to build the thing you're trying to get, right? So first it will check if it's buildable, and that's where the call to the make happens again. If the thing you are trying to build, it's another abstract, can't be built, it will call the make again against that. So the concrete here, it's used to as an abstract, right? Which it is because it can't be built. But if it can, then it will call the build method. So in the case it called the make method, you will see a recursion here because the make will call resolve. So it will be the second level of resolve being called just to be able to make something, right? So Laravel, the container, it's using the resolve to recursively to resolve the thing you called, right? Because of that possibility that you can register a concrete against an abstract, and the concrete could also be an abstract, right? That has another concrete register against it. So that's where it happens. But in the case of the HTTP kernel, it is actually a singleton, right? And the singleton, the kernel, it's registered as a singleton using a callback. So the build method will be called here because the concrete, it's a callback. And we will take a look how it's registered here. So if you remember, the application uses the configuration, right? So foundation, configuration, the application builder, and with kernels. So this with kernels, it's called from the application here, from the configure, I think. Yeah, see, with kernels. And it will register the kernel, HTTP kernel, against the contract as a singleton. And this singleton method, it's a container method. Let's just go to the container singleton. And it will bind passing this parameter as true, right? And that parameter bind function, it's the shared parameter. So it means that thing you are trying to bind, it's a shared concrete, right? Meaning it will be shared between all the client code requesting for that. It's a singleton, right? So the shared here, it's just implementation of the singleton principle pattern, sorry. Then what happens is that to build a singleton, when you don't, you just pass a class, not a closure, right? Laravel, for consistency, will get a closure for you. So that's the closure that will be called whenever the kernel contract it's built, right? Because that's the concrete of the abstract, the kernel contract abstract. And this will try to compare if the abstract is equal to the concrete. It means that it's really a class, and it will try to build. But in this case, the abstract, it's the contract, the kernel contract, and the concrete, it's the kernel class. So it's not going to be here. It's going to execute this part, which will be the resolve call again, because this time we'll try to resolve not the interface, the kernel interface, but the concrete, so the actual class. And that's how the closure works for the singleton. So we will be able to just follow here, but we'll take a look more specifically to the kernel. Let's just follow the overall structure. So the build, it's called, and the build will try to see, okay, it's a closure or it's something else. So if it's a closure, it will just call the closure and return the result, right? But if it's not a closure, then we'll try to use reflection to resolve the dependencies. Might be a class, right? So we'll check if it's a class and if it's buildable, it has a constructor. It will try to resolve the dependencies, and that's where the magic happens when you try to make something that has dependencies in the constructor parameters. You will use reflection, PHP reflection, to get information about your class and resolve the dependencies. So resolve the dependencies means building the dependencies and using those dependencies already built to build the instance, right? The concrete that you're trying to build, and then return to the resolve. And then the resolve will extend the type. This is just an extra functionality that you can register extenders to do custom things for your concrete, and then fire the callbacks after resolving to allow also custom code like packages to do more things after the resolve it's done, right? So the build method, how does it resolve dependencies, right? Using the reflection. So it will get the information about the parameters, the constructor parameters, and call this resolve dependencies. The resolve dependency will iterate through each dependency and will try to override parameters. And this is just that implementation of that functionality make with. You can pass parameters to make the concrete you're trying to make with the parameters that you are passing. So it will check, okay, this parameter has the same name of any parameter override that I have. If yes, then I will just use that value, the passed value. But in the case of the kernel, the kernel, when reaches the build here, and when it reaches the build with the not the closure, but with the actual class of the kernel, it will try to resolve dependencies, and the kernel has some dependencies. If you go to not this one, go here, it's foundation HTTP kernel construct. See, it has the app as a dependency and router. So when we reach here, resolve dependencies for the kernel, we'll have two dependencies to be resolved. We have no parameter override, so we will have to resolve the type, first the app, then the router. And to resolve that, then the resolve dependencies we call the resolve class. And the resolve class will call make or use a default value. Because the default value, it's, for example, you have a constructor that accepts a string, and the string has a default value. Strings can't be built. The container can't resolve them, because how you build a string, right? But they can use the default value. So if there's a default value and the resolve class can't resolve that, then it will use the default value. And if there is no default value, then it would just return nothing. But well, it would return something that the rest of the system will understand that can't be resolved, that dependency. But the make here call, it's whenever you have a class that can be resolved, right? And that can be built. And this is where another level of recursion happens, because the make will start all the process all over again. Make will call resolve, that will call build, that will call resolve dependencies if there are any. So we can see that happening if we do this, and I think it will be clearer when we do it. First, let's die here after we build the kernel, right? So you can see here we have the kernel build and the execution stopped there. So after we do that, let's go to the make method, function make, and let's do a echo making abstract, and then let's just break here, and then the sorry, I want the make, not make with. Function resolve, and here we will resolving also abstract. So if we execute now, you can see that the first making it's against the contract, the kernel contract. That call was from here, right? Make and pass the kernel contract. The second call resolving, oh, sorry, let me just fix that. The second call resolving here, eliminate contracts HTTP kernel, it's because the make called resolve, right? Using the same abstract, that's fine. The third call resolve, it's with the actual class, the HTTP kernel class, right? And this is happening because the first call, the resolving against the contract, got us a concrete, and the concrete was the callback, right? We can check that if we do this, if abstract equals to, let's just eliminate, this is the contracts, right? Contracts HTTP kernel, that's the contract, right? Contracts HTTP kernel, yeah. Then we will die and dump on concrete. You can see that the concrete, it's a closure, and the closure coming from the application, right? And using the abstract and the concrete, that's exactly the closure from here, get closure. And this get closure was just the concrete register against the HTTP class, right? The contract, when the singleton was called from the application builder here. So this closure here, what it does, it checks abstract equals concrete. It's not abstract, it's a interface, concrete, it's a class. Then it will call this container resolve, and you can see that it's calling without raising events, right? And this happens because it doesn't want to trigger all those custom callbacks that packages might be registering before and after resolving, because it's resolving not a different thing, it's just resolving the contract, the HTTP kernel contract still, but it's calling the callback, sorry, it's calling the resolve against the actual concrete this time. And here the concrete will be, let me just not die here, let's just do this. Here the concrete will be the HTTP kernel class itself, right? So that's why the third resolving here comes from that abstract, comes from that callback, right? And then we have a making app here. What is this? Why app router and events? This is coming from the resolving the kernel class calls the build, right? Remember, we have this build. Then you call closure or try to build, and in this case it's not a closure, it's a string. So we can see that here it's buildable, build, and then we can just copy this because now we want that into something else. So function build, let's just do this, stop equals false, and then stop equals true, so it's easier. This is the actual class, so it's eliminate foundation HTTP kernel, right? And then here you will be able to see that if stop die and dump the concrete, just to make an example. No, I'm just die dump abstract stop equals true, eliminate foundation HTTP kernel, right? Eliminate foundation HTTP kernel, yeah. It should be if stop the concrete. Am I stopping here? If stop here. No, what's happening? Concrete, echo, concrete. Let's just see. Oops. Echo, oh, concrete, it's not a, let me just go to the logs. Object or class closure could not be, okay, yeah. So this is a closure, but this is the first time, right? It's the singleton closure. And I know why we are not getting concrete. Okay, yeah, here, so here we can, if stop, then we do just the concrete, and we will see that it's the foundation HTTP kernel, right? And so it passed that, it's not a closure anymore. So we'll try to start getting information about the concrete, the actual class, using reflection. The reflection is just the PHP functionality, right? To get information about the class. So we can see here, we will have a if stop, then we will die on the reflector, and we'll see it's a reflection class from get information from this class, the HTTP kernel. It implements the contract. It has some properties. All the properties are listed here. All the methods, the constructor, it's listed here. The constructor parameters is listed here. So you can see that all the class information, it's available for the container to do the magic, right? To start instantiating any requirements, any dependencies. So that's what it's doing here now. Finally, it's checking if it's instantiable. If it's not, then we'll just return something that, because you might, if you do something like this, contracts, then we will reach that point, because the concrete, it's a non-instantiable value. It's an interface, right? So it's an error. The client code is just registering something that makes no sense. So we have this here, but in our case, we will have something, it's going to be instantiable. And the build stack, it's just to keep record of what it's building. Remember, this is it's a class that works in recursion. So it will have a lot of calls to itself, and it's just going to build a stack of elements that are being handled here, probably to keep track of everything. But that's what's happening, and we can even check later. Echo. Well, we can do a var dump, right? Probably this build stack. We have the kernel, then we are making, resolving, and then we get the kernel. So this build stack here, it's just called once. Why does it the app router, the build stack doesn't reach that point. The execution doesn't reach that point anymore. I think the app it's already resolved and the router as well, right? Probably. So whenever this was called, those two were already, let me check. This get bindings, they're registered here, right? So events and application, it's not here. Okay, let's move on. Maybe this will make sense a little bit later. But let's save this without that. So we are here, like, right, resolving the HTTP kernel, and we identified some dependencies by just getting the constructor, and if it's there's no constructor, then it's good because we can just instantiate the class without resolving the dependencies. So we just pop the build stack, an item from it to make it correct, probably. And then if there's dependencies, then we get the dependencies constructor, get parameters, and the dependencies will be here. We can take a look at that. If stop, then we die on dependencies. You can see two parameters, the app and the router, right? And then we will try to resolve dependencies, and that's where here we are in the structure here, resolving dependencies for the kernel, and we can go here, resolve dependencies. Let's just do this. Bool stop equals false, and here stop. So we just can keep going here. Let's just test it. Did I remove the stop from up here? Yeah, I did. Okay, so if stop die on the dependencies, it will be the same, but just check. Yeah, it's here. So that's where it iterate through each dependency, try to see there's a parameter override. Let's use it instead of trying to resolve the dependency, right? In our case, there's no parameter override, and then it gets it keeps executing and try to resolve a primitive if it's a primitive, right? But in our case, it's a class. It's the app, right? We can check here the get parameter class name. It's just doing that. It's if stop. Well, we have that in our. We do utility get parameter class name. We pass the dependency. See, that utility just gets the class for the parameter, and the class it's the application. So that's being used to check if it's null. It makes it's because it's not a class, right? It's probably a primitive. So if it's not null, then resolve the class. In our case, it's resolve the class. So we then reach the end of the execution, not the end, but the lowest level, to resolve the class itself, right? So resolve class will then check if the parameter, if the function accepts any number of parameters, right? It's variadic, and in our case it's not, so we will be able to call the make right away. This resolve variadic class, it will call make for any number of parameters. I didn't take a look at this exactly, but in our case it will just make, and this will also probably use make, but any number of times it needs. So here it's where the make it's called again, but against in our case against the application, right? So we can do this if parameter name equals to app, then we do a die on the parameter here. Parameter name equals app, but that's not the error, right? Probably not. Load file. The error is object closure cannot be converted. Oh, of course. DD. Well, DD will convert it already, right? Yeah. So the parameter we are handling, it's app, right? And in here, when we call this make against this, passing this value, it's passing the class, right? String. And then if we remove this die here, why does it then print this making app? Because if we take a look at the make here, function make here, we're just echoing whatever abstract is. So we saw the make being called, passing the class, and here it's just app. That's why that's because the application is extending the make method. If you go here in the application, remember the application extends container, but also it's extending the make. It's doing more things here, and it gets the abstract, and it tries to load the third provider if needed. This is just to implement another feature because service providers, they might provide access to classes that we are trying to make, right, to the abstracts. So the, Laravel doesn't want to load all the providers right away. That's why you have that in your provider. You can tell which services making, meaning classes, you are providing to the application, because then Laravel can defer the provider load, and only loads whenever you are the client code it's trying to make the class that your provider provides, right? So that's another functionality. We won't cover it, otherwise it will be too much content, but it's here, and that's why the application, it's extending the make method, right? And here there's a slightly it's what's the name? It's oh my god, it's a side effect, right? It's not expected that the abstract gets changed here, but it does, because it's doing this abstract equals to get alias. So that's the alias thing, and that's why we see making app here, because we get this abstract, which is the class, and we get the alias for that class, which is the app, right? If we do here in the container, when we resolve class, right? Resolve class, we can do it from here, probably. We have the stop here, right? Yeah. So if stop, meaning we are handling the app dependency, we can just die on this get alias dependency. Well, we have to do this. Here just delete this and another one. So you see it's app, right? So we get the alias, and that's why this here, sorry about that, it's calling the parent make with the alias already, because this is replacing the class name with the alias. And then we reach that function make, where we can log the app, right, being resolved, will be resolved. So making app, then resolving app, because make will call resolve, right? And then it's returned after the app is built. It returns to the resolve class that returns to the resolving dependencies for the kernel, and then it will resolve the next dependency. The next dependency is the router, right? So it will do the same thing, making router, resolving router. It will return to the resolving dependencies for the kernel. It will instantiate the kernel, because the kernel already have all the dependencies, and will return the kernel. But before that, we have also this making events and resolving events. Those are the third level of making, because the router also has dependencies, and one of them is the events, right? So before the router gets built, it also has some dependencies to be resolved, and then that's why this making events and resolving events are logged here, because the resolving router will call the build. The build will see, okay, it's a router, I can instantiate it, let's resolve dependencies, call the resolve dependencies on the parameters, and then the resolve class will call making against the events, right? So that's basically what happens, and in the end you will have handle request. You'll have your kernel here ready to be used, and there's another thing here, benefit of using, of course, the container, is that if we do start equals high resolution time true, then here it will be the end, high resolution time true as well, and I want to echo the end minus start plus a break, right, break. And I want to do that again. I want to call make again, and then die. And you will see that the second call, it's first it takes some time, and this again it's something like this. It's a nanosecond, so it would be something 1, 2, 3, yeah, pretty fast, right? it's not even readable but this one, it's even faster, right? Because it's 2 digits less, so it would be 0, 0, that, right? And that happens because when we call the second time, it's a singleton that's already built, so it keeps everything here, and it just make resolve, and resolve will see, okay, we have a singleton already, let's just return it, and that's why it's way faster here. So the container, it's a very intelligent, I would say, not intelligent, but it's a sophisticated place for you to store things that will cause some overhead initially because of all that registering things and trying to use reflection to understand your object that you're trying to build a class and resolve the dependencies, etc. But that overhead in some cases might be actually a performance boost, because you will make sure that you don't spend processing power building things again all over again that were already built. And on top of that, it's not only the object itself that you're trying to build, but also the parameters. The parameters are also might also be objects and from classes, etc. And those can be stored in the application as well. So if you're trying to make a component that receives the router and the, I don't know, the request or any other contained object, it might be good for you to make your component from the container, because the container will already have those dependencies that you need already built and instantiated. So it will speed up the making your component for you. But, and that's a little bit of course silly, but if you have a component that doesn't have much dependencies, or your dependencies are easily instantiated and your component it's just used in one place or two, and you can, even if it's used more, you can isolate that into the instantiation of that into another class, etc. It's better to manually do that to instantiate your dependencies and then your component than using the container, because the container has that, of course, overhead, that the processing of all that logic that will take some time, right? It's really fast, but if you were instantiating 100 times your component, let's say in a loop or something like that, it's wasting just performance. If, of course, and again, if you don't benefit from the container, right? So you don't, if you're not using parameters or classes that are already built in the container, if your component, even if your component uses some already built dependencies, you can always do this make and then pass the dependency here, right? And then instantiate your component with your dependency, right? Because that will be faster than just making your component right away. But yeah, so that's the take here. Container, it's very good. It adds some logic to be executed, and it takes a little bit more time to do that compared to instantiating by hand. But of course, if you're using your object throughout the whole application, if you want your the thing you are registering to be extended by other client code or other custom code, there's a lot of benefits of using the container. It's just that you have to keep in mind that it has a cost, right? It's very small, but it's just good to know. So that's it. I think we covered how the kernel gets built, the container logic around it as well. And next time we'll start taking a look at the handle method from the kernel, finally. And I hope you guys learned and liked to understand a little bit more the logic on the container, and we will see in the next episode. Bye bye.